In today's video, we're going to look at the three states of matter: solid, liquid, and gas, and see how substances can change from one state to another. To do this, we're going to use a model called particle theory, which helps us explain how the particles in each state behave by considering each particle as a small, solid, inelastic sphere. In solids, there are strong forces of attraction between the particles, which holds them all close together in a fixed position, to form a regular lattice structure. And because the particles are fixed, the overall substance keeps a definite shape and volume, so can't flow like a liquid. The particles can vibrate in their position though, so you can imagine them constantly jostling against each other. Now, if we heat up a solid, its particles gain more energy, and start to vibrate even more, which weakens the forces between them. And at a certain temperature, which we call the melting point, the particles have enough energy to break free of their bonds, and the solid melts into a liquid. In liquids, there are only weak forces of attraction between the particles, so they're free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles tend to stick together and are fairly compact. This means that liquids have a definite volume, even though their overall shape can change, and so flow to fit a container. If we then heat up our liquid, the particles will gain more energy, and this will make the particles move around faster, which weakens the forces holding the particles together. And once we reach the boiling point, the particles will have enough energy to break the bonds altogether, and so the liquid boils or evaporates into a gas. In gases, the force of attraction between the different particles is very weak, so they're basically free to move around by themselves. This means that gases don't keep a definite shape or volume, and instead will always fill a container as they spread out as much as possible. We normally say that gases are constantly moving with random motion, and this can be a bit confusing, because gas particles actually move in straight lines. They don't randomly swerve. What we actually mean by random motion is that particles can travel in any direction, and they'll end up being deflected by solid walls or other gas particles randomly. When we heat up a gas and the particles all get more energy and so travel faster, the gas will either expand, if the container it's in is expandable like a balloon, or if the container is fixed, then the pressure will just increase. On the other hand, if we cool the gas down enough, then the particles won't have enough energy to overcome the forces of attraction between them, and so bonds will start to form between the particles, condensing the gas into a liquid. Then as we cool the liquid even further, the same thing happens. The particles won't have enough energy to overcome the attraction between them, and this time even more bonds form, fixing the particles in place and freezing the liquid into a solid. Now, the last thing we need to mention is that the particle model we used for explaining the states of matter isn't perfect. In reality, particles aren't actually solid, inelastic, or spheres. Instead, they're atoms, ions, or molecules. Another issue is that the model doesn't include any details of the forces between the particles. For example, it doesn't consider how strong they are or how many of them there are. That said, models like this are still a useful simplification that allow us to understand a complicated concept. Anyway, that's all for today.